Just before going on with the quiz, we're just going to do some recap of where we were. Yeah, so this is the whole. Okay. Yeah, so this is the more simplified problem. So here we were. So maybe some of you had the chance to see on the website that the class notes that I shared. They're in French, so they should help you quite a bit to understand what's going on with this intertemporal uh, model. So what you have to know is that instead of trading good A and good B, I'm trading consumption today and consumption the next period. But other than that, all the same logic applies. This in the same way as I have some positive utility for consuming some good, but there's decreasing returns to consuming more of it, then it's the same thing for consumption in period T and in period T plus one. There is decreasing returns to consuming too much. So then we can just do the same type of problems. Here we would have U of good one, U of good two. Now we have U of CT, U of CT, T plus one. And the budget constraint is simply this. So first of all, this is the entire income I have in my life, omega, and I can spend it between since omega is earned in period T, then I can substitute directly some omega I earn for some consumption in period T, and I can keep some of my omega that I earn and spend it in period T plus one, but then I have to account for the fact that my purchasing power might have changed. So if there's there's positive inflation, then I'm going to be able to spend less, or rather I'm going to spend all of it, but then consume less because the euros I have accumulated allow me to buy fewer stuff. And if I have negative inflation, then I'm going to have more purchasing power. And the other limit is simply that so consumption in period T has to be between 0 and total income. So what this means is if I did spend more than my total life income in period T, then it would mean that there would be no way for me to reimburse what I would have had to take more debt than my lifetime income, so I would die in debt, and we don't want to allow that. We want people to be honest citizens. And then we were talking about these three possible solutions. So the ones that we're most familiar with is that one, the interior solution, in which I choose to consume some of it now and some of it in the future, because I don't like to starve to death now or starve to death in the future. But we want to maybe consider the crazy possibility that people may lose faith in the future and decide to consume everything now. So also that's this one here. And the third one, we don't want to care about it. So this was the result. Yeah, so it looks exactly as before. It's just that the total income, instead of being I, it's omega. So if I spend all of it in period T, then I can consume at most omega. If I spend all of it in period T plus one, I can consume at most omega divided by 1 plus pi T, the inflation. And normally I would get something like an interior solution, which would look like this. And but we want to allow for a crazy possibility of a corner solution in which I consume everything in period T. All right. So okay, I hope some of you have tried to look at the notes in French if you're not familiar with this model, because now we are going to have a small quiz about it. So of course you answer by looking at the plot. And by the way, if you think that some questions are not easy, it's normal. So that's when I wrote the quiz. I thought, okay, yeah, it's easy to think about this, but no, it's not that easy. So if you think it's difficult, then okay, it's fine. We can I can explain to you what's going on. Also, this was the equivalence of interest rate. Basically, the fact that what we're just saying is that having inflation is a bit like an interest rate on holding money. So if I have a positive inflation, then it means that I have a negative inflation of, so it's like if I put money in the bank, but instead of giving me a bit more than what I put in when I open my bank account, then the bank takes away some of it. Why? Because there was this inflation that took away part of my purchasing power. So there's just this equivalence between RT money and the minus inflation. And remember this formula. This formula might be useful for you in the quiz. All right. So yeah, actually remember that formula well. I think I'm going to copy it. If I can. Okay. So here's the quiz. In the interior solution, what happens to CT at period T? So consumption, present consumption, so per consumption when our generation is young. If inflation goes up, in the interior solution, what happens to CT T plus 1 if inflation goes up? So if inflation goes up, how much will people decide to spend more or less in the next period T plus 1? In the corner solution, so here are these were for the interior solution, this for the corner solution, of course the one that we care about, so the one where we consume everything today. So what happens to consumption today? If so, basically, do I change my decision? If inflation goes up, what happens to consumption in the future if inflation goes up? And then 5 or 6. So 5 is what would happen to the real interest rate on money, our money, that corresponds to an inflation rate of plus infinity. So imagine that inflation is plus infinity. What is our money? And then with if inflation is plus infinity, so if there's infinite inflation, what type of solution is most likely? So am I most likely to have a corner solution or an interior solution? And just to help you answer 5, I'm going to paste this thing there. So this is helpful for answering 5. Yeah. All right. Okay, so you answer here. HTTPS Google site, so it's quiz number 5. So are there questions about the material, about the quiz? If not, then go ahead and do your best. And by the way, I'm going to help you answer question 1 with a small quote that I found in the New York Times that I really liked. Okay, do people need more time? I have 23 answers. And we are 46 people doing the, okay, yeah, it's still entering. I don't want to rush you, you have to, you know, if you're familiar with the model, it's easier. Okay, oh yeah, 20, each time I think it's, so not bad. I'm quite impressed. Well, some questions are not too hard, but some are tricky. Okay, I think we can move on. Otherwise, it's so click randomly for the rest of the questions or the answer. No, or say I don't know. I don't know if I remember. If I put I don't know as a possible choice. Okay, so question one. Yeah, the question one. Actually, the question one is the. Oh no, I didn't want to show it. Okay. So imagine you haven't seen the bars. In the interior solution, what happens to CT if inflation goes up? So yeah, the most popular answers are consumption goes down or consumption goes up, or also ambiguous. So do somebody want to share their thoughts about it? Maybe I don't know if I can see the. Oh yeah, okay, we can use that. So nobody has any idea? You just answered at
Yes.
random? Okay, go ahead.
Okay. So if inflation goes up, then the curve of um, the blue curve will shift a little bit downwards, and then but we can see that the corner solution can be either on the left of the, no, not the corner solution, the new solution will be either on the left of the interior solution or on the right.
Oh, that's very good.
Depends on the shift of the curve.
Yeah, that's exactly right. So we can't say for sure. And now let me give you economic interpretation. But actually, so yeah, let me go back to my citation here. So here I added this quote there by Tyler Cowen. So he says, if the Fed promises to, so yeah, it was a discussion about how to stimulate the economy, and basically the fact that yeah, we should prime up the pump basically, or encourage people to spend. So he says what we should do is the Fed should start to increase the money supply. So he says if the Fed promises to, so that's in the US, the Fed is the Federal Reserve. So if the Fed promises to keep increasing the money supply until prices rise, say, by 3% a year, then people should eventually start spending. Otherwise, if they just held the money, it would be worth 3% less each year. So here, so that's in a New York Times article. So Tyler Cowen is, so, and he's a very, very smart economist. If you're interested in, so he has very deep insights into many things, and he has a blog. So I encourage you to look at what he's writing. But then, so here, what is he saying? He's saying basically, if we increase inflation, then people will start spending more right now. Otherwise, if they just hold to their money, then their money will lose value as time goes on. So they will be incited to spend it now. So what he's saying there is that there's it's going to create a different value of money over time. So he's talking about what we call the substitution effect. So there's the, so he's saying, yeah, the relative value of money will change over time. So I'm going to substitute spending right now compared to spending in the future. So why is he wrong? Because that's not the right answer. Is we don't know, it's ambiguous. So what I'm basically saying is there's no shame in not being completely sure about these things, because microeconomics is tricky sometimes. So I talked about substitution effect. So maybe that's a hint that there might be something else going on.
if the inflation goes up, people might prefer consume at time t than at time t plus one. No, no, people will prefer consume at time t plus one than at time t because they would consume more with the same amount of money.
No, if inflation goes up, inflation is how prices increase, right? So more inflation means prices increase faster, and higher prices mean that if I exchange some money for some goods, then I have to give up more money for fewer goods. So if inflation goes up, then definitely I know in the future that I'm less able to consume. But there is one reason why. So now we're not talking about consumption in the future, but consumption now. So if you remember, I don't know if you remember your Slutsky decomposition, or maybe I don't know if you've seen that, but basically I taught that in microeconomics before. So in Slutsky, have you heard about Slutsky decomposition or not?
Yes.
Okay, so we had two effects in Slutsky decomposition. So we had substitution effect and
income effect.
Yes, income effect. And what does income effect mean? In an intuitive sense, no need to.
If inflation goes up right now, we'll be able to consume less right now. Then that's the income effect because we'll have less money available to spend.
Yes. So okay, that's the like 80% the right answer. So yes, we have two effects. So substitution effect and income effect. So what happens is I know my money in the future allows me to buy less stuff. So for sure, I want to spend it now instead of in the future. But there is this other thing that if I have, if my money allows me to buy less stuff, my purchasing power has decreased. So it's like being poor. And I can think, oh, I don't want to, yeah, I know that my money is not worth a lot in the future, but still I don't want to die in the future. I want to still be able to spend. So maybe what I can do is I definitely have to save more in order to still have enough money to buy something in the future because I'm going to need a lot to buy stuff. So you have these two effects that are competing. So first of all, it's I want to spend more today because my money is worth more, but also I want to save more for tomorrow because I know I'm going to need more money tomorrow. So these two things are contradicting each other in terms of in my decision for consumption today. All right. Oh, and actually I can show you on the graph what it looks like. So yeah, so yeah, imagine that my inflation goes up. So this was perfectly answered by the first person. So what happens to the consumption today, which is consumption here? Well, maybe my green curve looks like something like this. So imagine that that's my green curve. Or maybe it looks something like this. So these two things are possible. And in that case, then my consumption would have decreased. So it was here and it decreased to here. And in that case, then it would have increased. So in that case, the substitution effect is more important, and in that case, the income effect is more important. So that's why it's ambiguous. Okay, so let me see how many of you got it right. Yeah, most of you actually. I'm quite impressed. Good. I think that was the hardest question in the quiz. Okay, second question. In the interior solution, what happens to consumption in time t+1? So does somebody have an opinion on that?
So in time t+1, the inflation goes up, the curve will shift a little bit down, more like the question before. So consumption in C+1 will go up.
No, go down.
No, we go down. Sorry.
Yes. Yes, good. Thank you for the second person. Yes, so yeah, it goes down. Perfect. So it's now the two effects go in the same direction. If there's more inflation, then I want to spend more today, less tomorrow. And also, if there's more inflation, then my global purchasing power in my life goes down. So there's that's the second reason why I want to spend less tomorrow. So good. Then in the corner solution, what happens to CTT if inflation goes up? Somebody has an opinion?
It will stay the same because if the curve shifts, it's only a matter of slope and not the entire curve doesn't shift. It's just
yeah. Let me express this in my own words. So if we have already a high inflation and we are at the corner solution, and inflation goes up even more, then it's pretty obvious just visually that, yeah, we stay there. So if we already wanted to not spend anything tomorrow, and there's even more reason to not spend anything tomorrow. So here the answer is perfectly non-ambiguous. I keep spending everything today. All right. And then the other is also extremely non-ambiguous. So it does not change. And for the, oh yeah. Oh, sorry, that was, yeah. 3, so what happens to consumption in the present if to the corner solution does not change? What happens to consumption in the future if inflation goes up? Then the same thing. I want to spend everything today, nothing tomorrow, and then there's even more reason to do so. So yeah, it does not change. 5. What? I can't see exactly. What would be the real interest rate on money, our money, that corresponds to an inflation rate of infinity? So, any opinion?
It's -1.
Yes, good. So
formula which above the decrease, and when fighting to infinity, we understand that thanks to the computation of the limit, it will be -1.
Perfect.
So we just have to solve the equation?
Yes, exactly. But so the tricky thing is, so this is the equation, but the tricky thing here is to just to keep you awake, that there is this about equal here for small inflation. So if you were not attentive, then you might think, okay, our money is minus inflation, so minus infinity. But of course, it's not it's not true for large value of inflation. Infinity is quite large, actually. So then you have to use the exact formula, and the exact formula gives you infinity over infinity here. So it's -1. Yeah, exactly. So yeah, most of you. Oh wow, I'm pleased that you understand what's going on. And what type of solution is most likely to occur? Well, we kind of know that it's a corner solution. Well, good. Okay, perfect. We're on the right track. Last year I gave this quiz and the answers were horrible. So I was very okay. I have a smart group this year. Everything's good.
Can I just ask a question, please?
Yeah, go ahead.
It was on the second question.
The quiz?
Yes. Yes, I don't understand what it couldn't stay stable. Because, for example, if someone wants to not consume the same amount of money, but to keep the same consumption, the real consumptions in goods, maybe because of the inflation, he will have to spend more money. So maybe CT plus 1 will be higher.
Okay. Okay, so that's a more tricky thing. Okay, so if you compare the model of consumption goods choice with this model, so in the consumption goods choice, then we had inferior good and normal good or superior good or luxury goods. And the thing is, some goods, if you have some goods, for some goods you had an income effect that was positive, and some goods you had an income effect that was negative. Why? Because so for instance, you have say a goods that you consume when you're poor. Then if your income goes down, then you would consume more of that good. So in that case, you could have an income effect that would have either sign. But in terms of intertemporal choice, it's total consumption. And total consumption is always a normal good in the sense that if you have more income, you consume more. If you have less income, you consume less. So in time t+1, the question is, do I want to consume more or less if the price of consumption tomorrow increases? Well, if the price of consumption tomorrow increases, then first of all, my money is less good tomorrow than today. So I'm more encouraged to substitute spending tomorrow to today. And second reason, if the price of consumption tomorrow increases, then it's like my total earnings of my life, which is omega, yeah, this omega there. Well, my total earnings allow me to consume less because if I consume tomorrow, then it's going to be a smaller consumption. So I have also less income, less real income in a way. So that's why it gives me a second reason to not consume more tomorrow. So here we read there's no reason why somebody would like to consume more.
Yes, so but for example, if in retirement I absolutely want to do something and I already know that it will cost me a certain amount of money, and if the inflation goes up, it will cost me even more, maybe I will save more money, and so CT +1 will be higher. I don't understand why it's not possible. Because if I absolutely need or absolutely want something on retirement, I will have to spend more money to have it because of inflation.
Okay, so so it's what you have as in mind as a model is you have some absolute necessity of something that you absolutely need to buy when you're so imagine that what you are the retirement package that you bought is they absolutely want you to buy exactly a certain amount of stuff, and you know if you don't do that, you're screwed. So yes, in this story, it's fine. So here, why it would not be the case, it's just because I put a bit more structure on the model, and I assume I assume that the utility is a constant function of C, and there's decreasing returns, and because of that, you don't have this type of necessary. I'm going to die tomorrow if I don't consume exactly that. But we can always, if we change the functions, then yes. So I'm going to, by the way, use exactly these things. So U of C equals log of C. So then we can see exactly what goes up, what goes on if inflation goes up. But so it's, yeah, you have a out of the box way of thinking, and it's good to always keep this in mind. Okay.
Yes, sir.
Yeah.
Do you have the time to explain once again the Slutsky effect? Or
yes. Okay. So it's not a centerpiece of the class. It's just yeah. So just in the 20-second again. So you get that part, right, or not?
yes.
So this is, if I wait, my money is not worth less, so I want to keep less of it. But then there's this other story, which is actually the exact story that the person said just before, is what if there is something that I really want tomorrow and I really need to buy it? So in that case, then, if there's more inflation tomorrow, there's inflation, then it means that I have to keep more money in order to be able to buy it. So there are these two things that go on. So that's why in period T, I'm conflicted, because on the one hand, I want to use my money when it's worth it to use it, but then maybe I want to keep some money to consume tomorrow. So what we're saying is the substitution effect makes me want to consume more today. CTT should go up, but the income effect makes me want to consume less today. So CTT would go down. Here, the consumption effect and income effect would go in the same direction. My income effect makes me poorer, so I want to spend less tomorrow, and my substitution effect makes spending money tomorrow less worth it. So I have two reasons not to spend more tomorrow. Yeah, so that's the last time I can explain it. What I can do is send you some exercises on exactly that. But no, it's not, it's subtle. And even this economist didn't get it right. So there's no shame in thinking that it's not super easy to understand. Yeah, but so these are basically more of a microeconomics foundation of our model, but they're not exactly required to. So what we really want is to understand money.
Okay, thank you.
Okay, so yeah, I spent a lot of time on these. So yeah, the answer here, harmony is just you plug in plus infinity and you get -1. All right. Okay, so let us go on. So the interior solution. Well, to get the interior solution, you solve it with the means you want. Usually we use Yeah, exactly. So usually we will use a constraint maximization if we don't have explicit formulas for U. So you cannot say use the constraint to substitute one of the utilities, for instance. So we solve it this way. I hope you have done that when you were younger, maybe last year or before. Yeah, so first order condition is that all the partial derivatives of L, which is my Lagrangian, with respect to Ct t plus 1, and lambda has to be equal 0. So we write it this way. This is nabla. It's I don't know if it's a Greek letter or not. Anyways, it means vector of first order derivative. So nabla of L here is just a vector of containing these three things. And there it's equal to 0, a vector of 0, 0, 0. So that's just a quick way of writing it. So if I derive this with respect to Ct, then I get here U prime of Ct. Here it's Ct plus 1, so no, plus lambda times minus 1 equals 0. So that's the first thing. Then this Ct plus 1 gives me here beta U prime of Ct plus 1 plus lambda times minus 1 plus pi t, the inflation, because I have my Ct plus 1 here. So that's this condition there. And then finally, I derive with respect to my Lagrange multiplier lambda. And so I just, as always, I get back my budget constraint. So I just get omega minus Ct minus 1 plus pi t Ct t plus 1. So equals 0. So these are my three conditions, first order conditions. So same thing if you did it with goods, then you would get first order conditions in terms of good. Here you get them in terms of consumption in the present and in the future. Of course, that's again assuming an interior solution. Otherwise, you couldn't maximize like this because you wouldn't get that tangent solution. All right, so yeah, what I can do basically here is just so use this condition to write U prime of Ct equals lambda, this condition to write beta U prime of Ct plus 1 equals lambda times 1 plus pi t, and then I could simply divide one by the other to get rid of the lambda. So that's what I'm doing here. And I'm getting this expression here, which is beta U prime Ct plus 1 divided by U prime Ct t equals 1 plus pi t. And this is what we call the Euler equation of intertemporal consumption. So it's a fundamental equation in macro or in economics in general. So it describes how I want to think about my spending in the present versus in the future, according to two factors. So the inflation, 1 plus pi t, and my preference for the present. So beta here, as a reminder, it's like you could think of it as equal to 0.9 or 99, for instance. So it's a discount of the future. And so I'm going to talk about what this means in general terms, but then we're going to put the analytic solution, analytic version of U, that was log of Ct, so it's going to be even clearer, I think. Yeah. So let me first start with these this general form, what this means. So if beta increases, what does that mean? It means that I value the future more because beta is so let me go back to my utility function. okay, yeah. Here's my intertemporal utility function. It was u of ctt plus beta u of ctt plus 1. So, and we say it's like 0.9. So if beta increases, it means that I care more about the consumption I get in the future. And if beta decreases, then it means that the consumption of the future gives me less utility, right? So that's what I mean by if beta increases. And then this is our solution. So okay. So if beta increases, what does that mean? Then it means that I have these. So of course, these two sides have to balance. And how do I balance them? Well, u prime of C decreases if C increases, because there's decreasing returns to consumption. So it means that u prime of CTT plus 1 would have to decrease to make, or with respect, in comparison to u prime of CTT, to make the equations balance. So it would mean that CTT plus 1 would have to increase. So that's what I wrote here. So if beta increases, then tomorrow's consumption has more weight in the utility, the intertemporal utility. So the individual would choose to consume more tomorrow. And if CTT plus 1 increases relative to CTT, then it means that u prime of CTT plus 1 would decrease. So it means that if I consume more tomorrow, then my marginal utility of an extra unit of consumption tomorrow is decreased. So then this ratio there would go down. So if beta goes up and the ratio goes down, then the equation is still maintained. All right. And the opposite is true for inflation. So if inflation increases, then the marginal value of savings decreases. So that's what we just discussed. There's this substitution effect that goes on. So CTT plus 1 will decrease relative to CTT. And here I didn't say the absolute change in CT or the absolute change in CTT plus 1. I just said the relative value of these two. Because as we've said, as we've just seen, they might be the effect that might be ambiguous. So yeah, this is a discussion with general utility function. Is it just enough for you to have one or two questions, or too complicated, or too simple? You can stop me now, but then what I'm going to do is use u equals log of c, and we are going to simplify this even more to have more intuitive answer. Okay, so I assume that either it's too simple or it's too complex to have an intuition. So here I'm just putting words to interpret this this equation there. So, but let me just put some structure. So I can actually write it. So if u of c equals log of c, so I'm just assuming now that my utility of c is log of c. Then I get that u prime of c equals 1 over c. Right? So you see what I'm saying is if you increase consumption, then the marginal utility of consumption decreases. So then we can just substitute u prime of c, u prime of ct plus. So what would this become? Then u prime of ct will just be 1 over ct. So I'm going to have ct at the numerator, and u prime of ctt plus 1 will be 1 over ct plus 1. So I'm going to CTT plus 1 at the denominator. So that's what we're just going to do next. So yeah, here we assume that U of C equals log of C. So I can simplify the previous relation with this to get this simpler form. So here I have that the ratio of consumptions equals to beta divided by 1 plus pi t. So again, all I've done, so here I solved this using a Lagrangian, and I use my two first order conditions to find this expression here, which is the ratio of the marginal utilities in the present and the future, which I call the Euler equation. And now what I've done is put some more structure by assuming some functional form for utility. And I get this exact answer. So my ratio of consumption has to be equal to beta over 1 plus pi t. And now I don't know, I don't have an answer yet for CTT and CTT plus 1, because I only used 2 of my 3 first order conditions. So the third one, just as a reminder, it's this one here. It's just the budget constraint, which gave me a second relation between CT and CTT plus 1. And I can use this second relation there to substitute either CT or CTT plus 1 and get an explicit answer in terms of consumption in the present and the future. And here I get this, this answer for consumption in the present. So CTT equals omega divided by 1 plus beta. So what we have had discussed previously is what's the impact of inflation on present consumption. And what we have said basically is that it's ambiguous. Well, now we know for sure that it's 0 because inflation is not present in this expression there. So that's a feature of the Cobb-Douglas. So this by using logs, it's exactly like using a Cobb-Douglas. And in that case, maybe you remember, but basically in Cobb-Douglas we found that this type of thing happened. It was that basically the consumptions were in silos, and whatever happened to, so the spending that you want to put in either one good or the other was fixed. And here that's regardless of price. And here that's exactly what we find. So inflation is the price of the future, and we see that in the present we don't care. So we know that we're going to be poorer in the future, but then again, we don't want to keep more money in the future. So basically, consumption in the present is just omega over 1 plus beta. And then consumption is in the future is omega times beta over 1 plus beta times, but divided by 1 plus pi t. So here inflation in the inflation really decreases consumption in the future. Okay, so now I talk, and I'm not sure if you're following me. Just to have to know if you are following along. So do I like consumption? If imagine I'm the generation who is born in time t, so my consumption in the present time is CTT, and my consumption in the next period, so in 30 years when I retire, is CTT plus 1. So questions, do I like or not like inflation? Again, the question is, do I like or don't I like inflation?
Don't.
Yes, I don't like inflation because if there's more inflation, my consumption in the present is exactly the same, but my consumption in the future is decreased. And I know that I like consumption. So because U of C goes up if C goes up. So I'm less happy. Yes. Oh yeah, so now what I can do is go back to my, go back to this budget constraint. And what I can do is substitute CT and CT+1 in my budget constraint to get this expression here, which is basically the, so what we can see is a sort of quantitative equation of money. So what? How did I do that? Well, I just substitute this and this, and yes. Just wondering where my oh yeah, okay. I use this this expression here. So so it's yeah. I just realized that it's I did some extra step there, and I shouldn't have done that. So here there's the price level. And here there was the inflation. So oh yeah, okay. So what I did is substituted inflation too, but that's totally not clear. So sorry about that. I shouldn't have done that. Because I was like, did price come? Here I have inflation. So yes, price, there is price in the future and price in the present. Yeah, so maybe I'll try to rewrite this better. But yeah, basically, trust me that what I did is I substitute CT and CT+1. Yeah, okay, so no, what I did is just substitute CT. Well, that's really not clear. I'm forgetting my own slides. Okay, yeah, so MT equals PT omega minus PT CT plus CTT. So that's my, okay, yeah. So that's my my budget constraint in the first period. And what I do is simply substitute CTT. And I get this, this expression there. Okay, and so this is a sort of a quantitative equation of money. Why? Because it links the money supply MT, so how much bills or how much M1, M2, M3 people have to exchange, so how much the government has supplied money, or the central bank, with prices, PT, and this is essentially the real output of the economy. So omega is what people produce, and it's multiplied by beta over 1 plus beta, which measures in effect how much, what fraction of omega they're going to spend in each period. So here there's one thing that's not there, which we have normally in the quantitative equation of money. It's the velocity of money, so how quickly people spend the money. So here we just assume that people spend it once and everybody spends the money, so there's no money that is not spent. So that's why we get this simple expression. And what do we see? Well, we see that there's MT is exactly proportional to the price in the price level in the economy and the real output. Or if I just divided by omega beta over 1 plus beta on each side, what I would see is that the price level is directly proportional to the money balances in the economy. So how much money supply there is, divided by how much goods you have to spend. Okay, so just to see if you guys are following, because I'm talking a lot. So what if people produce more? is it, and then and the money supply is the same. So what does that do to the price level?
Money supply will increase, no? Because we have W which is going to increase, so M will increase too.
Yeah, but so my question is, what if the money supply M doesn't change? What happens to the price level P?
It decreases.
Yes. So yes. So why? Because I have more goods to be able to buy with the same amount of money. So the only thing that can happen is that I can spend less of this money to buy the goods. So basically, there's deflation in the economy. But I don't want to say deflation because it's something that goes on over time. So here in this purely static, this purely instantaneous equation, what this means is if omega is bigger, then PT has to decrease. Okay, so we're almost done. So the general equilibrium. So we say that prices are taken as given. So this is the whole story of what goes on. So prices are taken as given, but then we're going to compute inflation later. The old generation gives money to the young generation. The total demand for money from the young generation is LT-MT. So MT is this fixed money supply that was created long ago and nobody knows why or how, it's just there. And so what is the amount of the total demand for money from the young generation? Then it's the total young generation, LT, times the money supply, MT. And what is the total supply of borrowing from the old generation? Well, the old generation has had MT T-1, and they were LT-1 people. So they arrive in the world, and they have this total supply of money, LT-T-1, MT T-1, and then the young generation, they want to spend, they want to buy LT-MT amount of money. So obviously that's a market. And how are they going to exchange this? Well, they exchange this by exchanging goods for it. And the equation on the money market is that LT-1, MT-1 has to equal to LT-MT. So on the money market, if it clears, then the total amount of the total supply of money from the old generation has to equal the total demand of money from the young generation. So again, my definition of the equilibrium, set of quantities and prices such that all agents behave optimally at given prices and all markets clear. So this is a market clearing condition. So then I can just use this to compute basically inflation. And how do I do that? Well, so LT-1, MT-1 equals LT-MT. But I know what is LT in terms of LT-1 because I know what is the natural increase of population. So LT is LT-1 times 1 plus n, the rate of growth of the population. And so I can just divide by NT-1 on each side, and I get this expression there, LT-1 equals LT-1 1 plus n times MT divided by MT. And then what I can do is use what I just computed here. So MT is equal to PT omega beta divided by 1 plus beta. And I know that MT-1 is going to be pt minus 1 times omega doesn't change. It's a constant. It's people always produce the same amount per person times beta over 1 plus beta. So this doesn't change too. It's the time preference. So then I can substitute mt by pt omega beta over 1 plus beta and mt minus 1 by pt minus 1 omega beta over 1 plus beta. And I get this expression there, but of course LT minus 1 can cancel out on each side. So I get, yeah, and these two things are all going to cancel. And eventually I get this extremely simple expression, 1 plus pi t minus 1. So inflation in the past is equal to, basically I just divide by 1 plus n on each side, so I get that 1 over 1 plus n here. So that's the expression I get. And what I can do is, yeah, subtract 1 on each side. And so if I do that, I get 1 minus 1 plus n. Minus 1 minus n actually. So I get minus n divided by 1 plus n. So I see that inflation yesterday is equal to minus n over 1 plus n, but n also is some constant, is the constant rate of growth of the population. So basically the inflation rate is constant and it's equal to always the same thing, to minus n over 1 plus n. So it's equal to, we can just write it pi t minus 1 as pi. So then what do we see? We see that if there is increase in population, then there is actually a decrease in price level. So do somebody have an idea for why this is the case? Well, mathematically we see it. That's surprising, no? Because we're used to having positive inflation. And now this model predicts negative inflation. So that's strange. So why do we see that? Well, it's because the amount of goods that people produce is always increasing, but the money supply is not increasing. So it means that for the same amount of bills, then I have to be able to buy more and more stuff. So it's just the ratio of money versus the amount of stuff to be bought is always changing. So it means that prices have to adjust. And here prices have to decrease. So the money supply compared to the real output is decreasing. So this is the prediction of this very simple model. And now we can look at what happens to people's utility over time. Yeah, so what we can do is just substitute CT and CT plus 1 and use again the fact that we know that U is a log of CT. So we can have an explicit expression and we find this expression there. Yeah, so is money neutral? Where here what we can do is, well, first of all, is money neutral in this model? So don't read the following. So just is money neutral, or is the price level affecting utility? That's not an easy question to answer. So I'm going to say it again. So usually in economics, we say that prices don't matter, because if I just double the prices everywhere, then the, you know, if I double the income of everybody but double the prices, then it shouldn't affect utility. Here I'm asking, is that the case or not?
Here the money is not neutral.
Here the money is not neutral?
Yes,
Okay.
I think.
Why?
Because utility is when inflation rise, you know, utility decrease. So
okay, perfect. Exactly what I wanted to hear. So it's the price level is not entirely irrelevant to people's utility, but it is still neutral in the following sense. It means imagine that my ancestors in many generations ago that created the money supply in the first place. So they could have created twice as much or 10 times as much, and it would essentially, for instance, double the prices in every period. So in that case, it would be neutral. But you're perfectly right to note that it's not entirely neutral, because what matters is how fast they increase. So not the exact nominal price level, but how the price level changes over time. Here it's exactly not neutral, because I have my inflation here. So are people more or less happy with inflation?
less happy.
Yes, because if their purchasing power will decreases, then it means that yes, they are less well off in the future. So that affects their intertemporal utility. And then what we can do is actually substitute this inflation, because we have an expression. We know it's always minus n over 1 plus n. And if I do that, I get this simpler expression. Here, there is 1 plus n. So in this model, do I want to have kids or not? Or do I hope that people have kids or not?
Yes.
Yes, exactly right. Because if n is higher, then my utility in the future is higher. So my intertemporal utility is higher. So here, kids are, in a sense, a public good, quote unquote. It means that if you have more children, then your pensions are worth more. So imagine that you have some pension fund that you saved, and you saved a couple of 10,000 or 100,000 euros if you're rich for your retirement, or millions. And so what this means is, whatever the nominal amount of money you saved, you have to be able to buy stuff with it. And if there are very few people around, so imagine that you're in Japan and people have a lot of less kids than they used to have. Well, no matter if on the computer it says that you saved a lot in your retirement account, if you have very few people working, then you cannot use this money to buy more stuff. It's just going to go into higher inflation. So really having kids in this model, but in general, it's not just, it's a very general conclusion. Having kids is a good thing for future generation. So if I was, back in the day, I was a farmer, then having kids is good for me, because they work in my farm and they pay me more. But that's exactly the same. Now it's just that my kids do other stuff in life, and they pay for the general goods that every old person can buy. So if we are going into a state in which population is not actually increasing all that much, but maybe decreasing, then it's not good. It's not good for retirement fund, exactly. Yeah, and it also good. One thing to note is that there's omega here that's stable, but of course, if omega changed, so imagine that omega could go up. So omega is how much people produce, how much each person produces. Then that would be something like if your kids are more productive. So imagine you had the increase in omega, then it would also be good for you. So it means that not only do you want more kids, but more educated kids and more productive kids that are able to produce stuff in the economy in the future. And what is going on with the retirements right now? Well, there's this thing that you might have heard of. Well, now we're scared about COVID-19 and everything else, but back a few years ago, and actually it's been going on for maybe 50 years, this huge problem of retirement. And you may have heard that so almost every French president always tries to reform retirement, and it's very difficult to do it. So here, this is the size of the retirement saving gap. So what is this? It's the amount of money that has been promised by retirement funds. So they say if you invest that much in your retirement fund, then we pay you that much in the future. Problem is, so what is the problem with retirement account? Why are they? So why is there a problem with how much money has been promised to previous generations?
Excuse me, I'm very sorry to interrupt you, but we have another lesson in 3 minutes, so we don't really have time. I'm sorry.
Wow! Okay, so I'm sorry, I just didn't see the. So thanks a lot. So, okay, well, think about this, and interrupt me if I'm not looking at my watch. Sorry, I forget sometimes. So have a good lesson, and yes, goodbye.
Okay.
Thank you. Bye-bye.
Bye.
Thank you. Bye.
Thank you. Bye.